Okay, so we're about 2/3 of the way through this lesson now. We're going to get through most of it in this video, and we'll have one, I think there'll be two more videos, and then we'll be all done. So let's start off with calling subprograms. Now, obviously, the purpose of subprograms are to group that logic outside of the standard logic to simplify the code and to allow repeatability. Now, of course, we want to be able to do that ideally in our pseudocode as well, because we want to make sure that things are organized effectively. Now, not all designers will use this. They'll just put everything in one spot. But sometimes you may want to enforce that there is some call out to some separate section of code. So how are we going to actually approach that? So we use the call keyword to indicate the calling of a subprogram in pseudocode. I'm going to pause for a second. You notice that I accidentally spelled pseudocode there with space in there. Now, if you Google pseudocode, you're going to find it spelt in a multitude of ways, whether it's like that with the space, whether it's like that without the space, whatever. To be honest, I've seen it used both in many different locations, so I'd accept either one, and I think it'd be, ridiculous to not accept either one. Anyways, so if the subprogram you're calling is a function, you're going to have to use that return keyword to indicate what value or what data is coming back and where it's going to be stored, right? Not the value itself, but you're going to be using these return keywords actually in a couple places, but to indicate where that data is going to be stored. And next, of course, for any parameters, we're going to use the with keyword, and we're just going to separate all of our parameters by commas. You might have multiples. You don't need to specify data types or anything like that when you're creating your parameters. The naming should be sufficient in order to determine what values or data types that the programmer should be using. So, quick little example. We're going to call a subprogram called exponent with a base and the value 2, which means we're calculating the square of something, right? Some base squared. And we're going to return, and when we return, we're going to store it in the variable called product. So call exponent with base and 2, return the product. So another one. Call average age with student ages. You'll notice the name of that variable is pluralized. That implies that it's a collection, an array, or something along those lines. Call swap with current item, target item. So basically, looking at this, we can clearly see that it swaps the values in those two variables, whatever those variables are. And then call get balance, return bank balance. No parameters there, but it does have a return value, which is going to be stored in the variable called bank balance. All right, fairly straightforward. What I want you to do right now is I want you to take a little bit of time to try and practice. So here's 3 questions for you to give this a shot. With each one of these questions, take some time, write the pseudocode. When you're done the pseudocode, either trade it with a friend or write the code yourself from your pseudocode. That means don't make any assumptions, don't make any guesses, only do the logic that's on the paper. If the program works as expected, you did a good job with the design. If it doesn't, or you have to ask questions of the person who designed it, then somebody needs to be more clear in their design aspect, in their design logic. So here's your 3 questions. Number 1, a program that asks the user for 2 integer numbers and prints out the maximum number of the 2, as well as the sum of the 2 numbers. Now we're going to see if you can get that, because I'm going to go through an example later on that's going to use that same aspect. Number 2, a program that asks the user for 10 marks and will output the number of passes, anything above a 50, and the number of failures, anything below a 50. I guess a pass would be above and equal to 50. Number 3, this one's a little bit more complex. A program that asks the user for the size of a pizza, the diameter. They want in inches and determines the cost of the pizza to the restaurant, not to the customer, but to the restaurant. You know that labor always costs 75 cents per pizza, regardless of size. And cooking energy costs $1, regardless of size. Materials cost 5 cents times diameter squared. So, the result is then going to be output to the user. So based on whatever diameter they enter in, you're going to calculate the final cost to the restaurant and then display that to the user. Straightforward. So pause the video here if you can. Go practice that stuff, and when you're all done, come back. I'll be here waiting. I'm going to continue the video now. I don't see a need to stop at the moment. So this would normally be the second day of pseudocode. If you're following on the PowerPoint, if I was teaching in a class, all that stuff that we just talked about would have been delivered in the first period, and now I'd be moving on to the second period. So, now we're getting into the loop side of things. So what are we going to do with loops? Well, we have a couple types of loops. We have conditional loops and counted loops. Starting with conditional loops, because they're the most straightforward. The while construct, we use this to specify some form of loop that ends when a test no longer succeeds, right? So while this condition is true, keep looping. When it's no longer true, stop looping. So the beginning and ending of the loop are indicated by two keywords. I bet you can guess what those are. While and while. That's it. That's all there is to it. Just like if and if. Exactly the same thing. General format. While some condition is true, do a sequence of code. Any sequence of code. You could even do nesting in here and have if statements and everything else inside of there. So while some condition is true, sequence, and while. So we already covered all this. That's great. At the conclusion, now this is very important. At the conclusion of each iteration, the condition is evaluated and the loop continues as long as the condition is true. So what that means is it's tested after the loop cycle is done. So it'll never enter the loop unless the condition is true, and it'll never re-enter the loop unless the condition is still true. Let's look at a simple example. While population is less than the limit. If that is true, we're going to recalculate population as the current population plus all the births minus all the deaths. And while, and then we're going to come back up to the top. Is the new population still less than the limit? Yeah, all right, let's calculate it again. And that will continue and continue and continue until the population meets or exceeds that limit. Then it's going to break out of that while loop and go down to the display statement. The world is full, time to go off-world. Let's go colonize. All right, so it's a very simple logic, but it's going to continue forever. Doesn't ever stop until that population meets or exceeds that limit. So in what case would that actually occur, or when would that actually occur? Well, if your births outnumber your deaths, then your population is going to grow. If your deaths outnumber your births, your population is going to go down. All right, so it's very simple. Let's go to the for. So this is for counted loops. Remember, counted loops we use when we know exactly the number of times we need to loop through some logic. Could be for any number of reasons. But very similar to the while loop, we have a number of iterations that depend on some keywords. So what are those keywords? Guess, for, and end for. Same stuff, right? Okay. Now there is one extra keyword that we're going to add in there as optional. So if you're writing traditional logic, like a traditional if statement, you might have something like for int I equals 0 such that I is less than 10, for example, I plus plus. Oops, not plus 6. I plus plus. There we go. So that means that we're incrementing the value of I by 1. But I could just as easily say plus equals 5. And then what we're doing is we're actually increasing by 5. Well, that's what the by keyword is. The by keyword is how much are you changing the value of the counter variable by each iteration. If this were minus equals 5, then that by would be negative 5. Right? Makes sense? Okay. So going on, let's give you some basic logic here. So for iteration bounds, by some change amount, do a sequence. You're like, well, that's not very clear, Mr. Lane. It's not very clear. Basically, we're saying for some range of data, do a sequence of logic. Okay, let's take a look at this. So here's an example of a good for loop. For each month of the year, display month name and for. So this is our sequence, our range of data for each month of the year. That's very clear. Well, we know which months there are in a year, and this implies that we're starting in the first month of the year, which would be January. It just says display month name. Okay. For month equal 1 to 12 by 1. Display month name. Same logic, exact same logic, not as easily read. It's not as clear. So yes, it does work, but this is not clear. And the point of pseudocode is to be very quickly understood. right? By reading this, I have to sit there for a second and interpret what's going on. Not that great. Another one. For each employee in the list, display employee name. Again, we're looking at a list of employees, and we're going to display each employee name. Very clear. For empnum equal 1 to list size, display emp name. Again, same logic. Not super duper clear. So we need to be much more obvious when we're writing these statements. English is fine. You want to be concise, and sometimes it's okay to put the math in there, but if it makes it any less readable, you should try to avoid it. So let's look at a few examples and wrap this whole lesson up. So, first up, set move count to 1. For each row on the board, for each column on the board. Now I'm going to stop for a second. Basically, think about this. It's a board, and it's got rows and columns. So what are we thinking? We're thinking either checkers or chess or something like that. That's what it's going for here, right? And right now we have our move count variable, which is currently set to 1. If game board position at row column is occupied, what does that mean? What we're saying is there a piece on the game board at this row and column? So this is probably an array of some kind that takes a row and column, and we're checking to see whether there's a value there or not, meaning is there a piece at that position? If there is, then let's call this subprogram called find adjacent tiles. Adjacent means touching with row column. So we're passing in the row and column that we're checking, and we're finding all the adjacent tiles. Now you might think, well, what does that mean? Well, think of a checkerboard for a second, or a chessboard, same thing, right? If you're looking at the top left corner of that board, it only has 3 adjacent tiles. It only has 3 adjacent squares. Right to the right of it, right below it, and down on the diagonal. If you're talking about a square in the middle of the board, well, then it's got 8 adjacent tiles. All right? So all we're doing is basically determining what the adjacent tiles for that specific row and column are. And then the increment move count, we're just saying, hey, every time we find a new piece, add 1 to the move count. That's it. So we're talking about the number of pieces that we can actually move. So this is a set of logic that does a fair amount of work. It uses nested for loops to go through every row and column of the board. If you look at this logic, it says for each row. So we're starting at the first row. And then inside that it says for each column. So on the first row, it's going to go column 1, 2, 3, 4, 5, 6, 7, 8. And then it's going to go down to the next row, column 1, 2, 3, 4, 5, 6, 7, 8. Because remember, the inner loop is going to completely execute before the outer loop goes to the next iteration. We did this a while ago when we first started talking about counted loops. All right, so this one's a little bit bigger. Set total to 0. All right. Set grade counter equal to 1. I'll be honest, I'm not sure why I wrote the words 0 and 1 there. The numbers would probably be better. While grade counter is less than or equal to 10, display please enter next grade. You'll notice I put my end while here so I know my container. Read grade. Compute total equal total plus grade. Increment grade counter. So let's pause there. What are we doing? It says while grade counter is less than or equal to 10. Well, currently grade counter is 1. So we're going to be entering in, we're going to be looping through this from 1 to 10, which means 10 times. Read grade. Okay, so we're asking and reading a grade 10 times. Every time we read that grade, we're going to calculate a running total. We're adding that current grade we just asked for to the current total. Total started at 0. And then when we're all then we're going to increment grade counter because this is a while loop, so we actually have to do that. So then it's going to go back up, and now grade counter is 1 bigger. So it's going to keep going until it's no longer within that bounds. So what we did, we calculated the sum of 10 grades. What are we going to do with that 10 grades? We're going to calculate its average. Class average equals total, the value that we calculated inside, the sum, divided by grade counter, the total number of grades we actually entered. Okay. Display the class average is plus class average plus percentage. So it's actually going to calculate that class average and display it on the screen. Easy peasy. All right, but there's a lot of different things going on here. We're starting out, we're assigning data to start with. We're creating a loop. We have a sequence inside. We have final calculation statements, and we have a display statement. Now, what would happen if I did that compute statement inside the while loop? Well, it would be wasted effort because basically you're recalculating the class average every loop. And the class average doesn't matter until we have all the grades. So there's no point. So it's better to pull that out. It's almost like factoring in math class. We're going to pull out the common factor, the thing that has to happen after the whole setup. Okay, so that's where we're going to stop. I'm going to go through a quick little example with you just to try this out. So let's say I have this question. Ask the user for 5 numbers and then display the maximum number entered. All right, so the first thing we need to realize is that we got to ask them for 5 numbers. That means that we're going to have to create a loop. And it says display the maximum number entered. Well, that means we got to track what the maximum number is. Now, there's a few assumptions that need to be made here because we didn't really clarify what the range of valid numbers are. It just says 5 numbers. So let's adjust this statement for a second. Let's say 5 positive numbers. All right, so ask the user for 5 positive numbers. Then display the maximum number entered. Okay, so we know since the 5 numbers are going to be positive, one of them is going to be, they're all going to be at least 0 or greater, right? Even 1 greater, I guess. So first thing I'm going to do is I'm going to create, or not going to create, but I'm going to set a maximum variable. Set, let's say max, equal to -1. Why -1? I'm specifically choosing -1 because I know that every one of those 5 numbers is going to be bigger than that, which means one of them is going to, at least one of them is going to replace that maximum value once I get into my logic. Okay, what's the next thing I need to do? Well, I need to ask the user for 5 numbers. So I need a loop. I know exactly how many times I'm going to loop. So I'm going to say for, well, I need to count how many times I'm going to do this, right? So let's say, now we could write this in as English, or we could do it very specifically as numbers. Let's say for each of 5 numbers. For each of 5 numbers and 4. So inside of this, I've got to ask the user for information. So display, please enter a positive number. Okay, and we're going to read that number in. Read number. Now, the whole point of this program is to find the maximum number. Well, how do I know if this new number is the maximum number? Well, if it's bigger than the current maximum value, that means it's the new maximum. Maximum means biggest. So I have an if statement. So I'm going to break this up a little bit for readability. If number is greater than max, I'm not even going to check greater than or equal to because I don't need to replace it if it's equal to because it's the same number. So if number is greater than max, then I'm going to put my end if there so I never forget it. And inside of here, I'm going to set max. We're going to say set max equal to number. Now, I didn't compute because I'm not actually calculating anything. I didn't compute. I'm not actually calculating anything. I'm just setting a value. There's no calculation here. It's just assigning a value. Okay. I don't need to do anything else there because if we look at this logic, it's going to say for each of 5 numbers, get the number, check to see whether it's bigger than the current maximum, and then do it again, and do it again, and do it again. We're going to do this 5 times. When it's all done, we just need to follow the final step, which is display the maximum number entered. All right, display the maximum number was max. And that's it. All there is to it. Now, if we were to go write the code for this, so now this is my design. Now I'm going to write the code for this. First thing I'm going to do is I'm going to need a variable for max, so int max. We're going to set that equal to -1. Now I'm going to do my for loop. For, let's give it a little space. Let's write a little line here. Code. For int I equals 0, shows that I is less than 5 because I'm asking for 5 numbers. And I'm going to increase by 1 each time. Inside of here, what do I need to do? I need to ask the user for that information. Console.write. Please enter a positive number. Oops. And now I got to read that number in. So I have to do console.readLine, but remember when we do readLine, it comes in as a string, so I have to convert. Now I'm not doing any error handling right now. Normally you would need to verify that it is actually a number that the user entered in, but we're just trying to keep it simple right now. So I would say I need another variable for number, int number. I don't have a value for that yet, but that's okay. We're going to get that inside of here. So number is equal to convert dot to int 32 console dot read line. And then finally, where are we? Now we need to do an if statement. We need to do an if statement that says, hey, is that new number bigger than the old number? Bigger than the old number? Maybe. So if number is greater than max, we're just going to set max equal to number. Again, no calculations are made here. Now I'm working in Notepad, so the indents are huge. I believe they're 8 spaces, which is massive. In Visual Studio, I believe they're 4 spaces. You can set that. I think you can even set it to 2, but the standard is 4, so leave it as 4. So finally, we just got to give our final display statement, which is console.writeLine. The maximum number was... Oops, I made that same mistake last time too. Typo. That's it. So logically, our code is no shorter than the actual pseudocode. In fact, it's actually a little bit longer because we have the brackets in there. But this is definitely less readable than our very English-friendly logic. Okay. Now again, this is also applicable to any programming language. I wrote it down in C#, or I wrote it down here in C#. If I were to write the exact same code or the exact same logic in Python, it's not going to look the same, right? If I wrote the exact same code in C++, it's mostly look the same in C++, minus a few things, how we do input/output. But pretty much the logic is dependent. The logic is independent of the actual implementation. So that's where we're going to stop for the day. I hope you learned something from this and how to do your design. Going forward, you should be ready for your next assignment. Good luck.